Hello guys, welcome back to my YouTube channel. Today we are going to solve day 11 problem. So the name of problem is maximum difference between node and ancestor. Okay, and we have given the root of a binary tree and we have to find the maximum value v for which there exist different nodes a and b, where value is a dot val minus b dot val and a is the ancestor of b. A node A is an ancestor of B if either any child of A is equal to B or any child of A is ancestor of B. Okay, so this is the example 1. So let's understand this with an example. Let me copy it. And here for this root the total output is 7. Okay, so to solve this problem let's understand with this example first. Let's pick out this part only first. Okay, so in this part, as you can see, let's say this 6 is the root. Okay, and this is the left side value and this is the right side value. So for what we are going to do for this problem, so for each node we are going to find the minimum and maximum. Okay, so for this node our minimum is going to be 6, and maximum is also going to be 6. Okay, maximum is also going to be 6. Then we come to this node. Okay, and here our minimum is updated to 4, and maximum is still 6. Okay, maximum is still 6. Then after that we go to the left of this one. If there is nothing in the left side, okay, so at that point we find the difference between this max and minimum, so total difference is 2. Okay, and then we go to the right of this node and again we find the total difference between max and min. So again there is a null node, there is no node, so we get the value as 6 minus 4 is equal to 2. So out of them both are same. Okay, so we can pass any value 2 here. Okay, let's say it's 2 here. Then we go back to this node. Okay, now at this point we total here at this point of time the minimum is 6. Okay, so from here we go to this right side. So minimum is 6 because this is a root, this is a parent, and our max is updated to 7 at this point of time. Okay, then we go to its left. So when we go to the left, then the total difference is 7 minus 6, 1. Then we go to its right, it's also null. Then again we find the difference, 7 minus 6 is 1. So here in this node we get the total difference as 1. So now here it's 2, here it's 1. So which is out of these two nodes we get the maximum difference in left side. So for this particular part the total difference that we get as output is 2. Okay, so I hope that you guys are able to understand with just this node. Total difference that we get is 2. Okay, so now after that let's see how we are going to solve this entire problem. Okay, so now here in this problem, so first we are in a root. So let's say I am storing first minimum here, and here in the next I am storing the maximum. So for this node both minimum and maximum is 8, 8. Okay, then we go to this left side. Then our minimum is 3 and maximum is 8. Okay, then we go to its left. Then our minimum becomes 1 and our right our max becomes 8 only. Okay, so we are following this path here to here, then we come to here. Then now we check for its left. Since there is nothing, so it is going to return 7. difference between max and minimum. 8 minus 1 is 7. Then we go to its right, since there is nothing, so it is also going to return as 7. Okay, 7 value. Then we go to the right of this 3. Okay, when we go to its right of 3, then our here our see, for this node minimum is 3, so 3 is minimum and 8 is maximum. There is no difference min max because it's 6. Then we go to this left side. Here also there is no difference, 3 to 8, 3 comma 8. Okay, so in whole this path you see minimum element that we encounter is 3 only in this whole path, 3, and maximum is 8 only. So when we go to its left, there node is null. Then at that point of time we return 5. When we go to here, then also we return 5. Okay, 8 minus 3 is 5. Now we go to the right of this 6. So at this point of time, 8, 3, 6, the minimum is 3, max is 8. So again we compare, so there is no difference here also, 3 comma 8, because minimum is 3 and in this whole path, and maximum is 8. So with here again we go to its left, difference is 5. Then we go to its right, then also difference is 5, so we return 5 here. Okay, so here difference is 7, here difference is 5, here difference is 5. Okay, and then we have already covered these nodes, this node. Now we go to the right of this one. So minimum is going to be our 8 and max is updated to 10. Okay, here max is updated to 10. Now we check for this left, because there is no left here for this one, so we are going to return difference. 10 minus 8, difference is 2. So at this point of time, for this node the difference is 2. Okay, 10 minus 8, 2. Then we go to its right. Here also now max is updated to 14 for this node. For this path, see this path, minimum is 8, maximum 14. So now we go to this path. So again here minimum is 8, max is 14 only. Then we go to its left, it is going to return 6. Then we go to its right, there is no null. Then again we are going to return 6. So at this point of time we store 6. Then we go to its right, since it is null, then at this point also we have checked 14 minus 8, it is going to return 6. Okay, so now here at this node the total difference is 7. Okay, so let's do one thing here. First compare these two nodes. Total difference is here 5 only, it is going to return 5 only, and here it is giving 6 only, here it is also giving 6 only, but here at this node it is giving the maximum result 7. So we are going to get the result as 7. Okay, 8 minus 1 is equal to 7. So this is going to be our output. Now let's see how we are going to write the code for this specific problem. Okay, so first in this function just return one more method, that is return DFS, as we are going to apply depth first search. So return DFS. Okay, and in this method we are going to pass our root, and then we are going to pass the minimum value. Okay, so here we are passing the minimum value. Okay, so can I write it like this? Integer dot max underscore value. Okay, so here we are going to need only minimum value. So if I am going to pass here max value of an integer, then obviously it is going to take this node value as min only. Okay, if I pass the max value here, because it is going to compare. Later on you will get better understanding with the code. So for max value I am going to pass the minimum value of integer. Okay, integer dot min underscore value. Now let's declare this method. So write private, and we are going to call the difference from here. So int DFS, private int DFS, and here pass root, and pass here in this we are going to get the our minimum value, and then here we are going to pass the max, get the max value. Okay, so now in this first we are going to check if the root is null. If root is equal to null, in that case we are just going to return what max value minus min value. Okay, so here you can see here this part. So here if our root is null, then at that time I'm calling the max value minus minimum value to returning this value to this node. Here when I go to this right, there is nothing, so I'm returning max value minus min value, right? That is why I'm writing it like this, return max value minus min value. Okay, so this is clear, I think. Now next we are going to get the min value. So min value we are going to get like this, min value, and here we are going to use this math function, math.min, and I'm going to get the minimum value from this root.val, comma, here root.value and current our min value. Okay, so here let's say this is the root. Okay, so if this is the root, then here root.value is 8, and min value, what value we are passing here? 8. So 8 we are passing, and here we are passing the maximum value. It is a maximum value of integer, so this is a maximum value of integer, and this is just 8. So minimum value we will get 8 only. Okay, that is why here we are passing max value. Now I think you guys are more clear if you haven't heard about these things. So now max value is math.max of root.value, comma, max value. Okay, so now here see, this is our root.value is 8, so here I pass 8, and max value, here in max value I am passing the minimum value. It is a negative value, so obviously this root.value is greater than this negative value, so that is why our max value becomes this root value only, 8. Okay, and now after that, if I want to get the left difference, like for this particular node when I was doing just for this one, so if I want to check for this left node, so here I am going to root.left. Okay, so here int left difference, to get the left difference, what I'm going to do, I'm going to just call this function again, this method again, dfs, and here in the root I'm going to pass left, and this is going to be same, min val, max val, not a steering cricketer, this is max value. Okay, and how I am going to get the right difference? Right difference is equal to dfs root.right minimum value and maximum value. Okay, so I hope you guys are clear here till now. And in the end, here also you know that I'm comparing what values I'm going to get. Like here when I go to this left only, okay, let's understand this only. So here when I go to this left, okay, so here I get two values. One is for this one, 6 minus 4 is 2, 6 minus 7 is equal to 1. So here which value is greater? This 2 is greater. For this specific part, this 2 is greater. 6 minus 4 is 2, 6 minus 7 is equal to 1, so this 2 is greater. So I'm going to get the return the maximum value only, maximum difference. So can I write it like this, return math.max, and in this I'm going to just write just pass the left difference and right difference, that's it. Okay, that's what I'm passing only, so right difference. So now our code is complete. Let's try to run this and see if it's working fine or not. So here there is some, okay, value v should be in small letters. Let's run it again. So our solution is accepted. Now let me submit it. Awesome. So our solution beats 100% of users with Java. So I hope that you guys are clear with today's problem, and if you have any doubt, then please feel free to ask in comment section. And if you like this video, then please share and subscribe to my YouTube channel. Till then, keep coding and keep practicing. Thank you. Bye bye.